Hello everybody and welcome to our RSK Sowing the Seeds for a Sustainable Food Chain webinar today. Thank you very much for joining us. I would like to introduce you to our panel for today. We're bringing together a number of RSK organisations who all contribute in different ways to the food supply chain. So we've got a number of different businesses here, but they're all part of the RSK Group. We were supposed to be being joined today by Dr. Ian Mugford from TerrAffix, who was due to speak to us about the use of biochar and its potential value within agricultural systems. However, unfortunately, due to unexpected circumstances, he has had to withdraw from the webinar. But if there are particular questions you had for him, do please ask them and we will pass them on and get responses for you. So I am also joined today by Ione Lee Smallwood, who is joining me from ADAS, and she'll be speaking about sustainability. I've got Gavin Ramsey here from PD&MS Group, who will be talking about waste management. I've got Jack Smales from Calibrate, who will be talking about heating and chilling efficiency, and Stuart Craig, who is joining from the RSK Group itself and will be speaking to us about innovation. And then there's myself, Sarah Wynne. I lead the ADAS Climate and Sustainability business, and I'll just be introducing this webinar and providing a little bit of background information about RSK. So thank you, everyone. So a brief introduction to RSK. So our services span the whole of the food supply chain, really, from pre-farm gate all the way through agriculture, manufacturing, logistics, and into the retail, catering and waste management areas. And we've got expertise in both the natural environment and the built environment. So depending upon whereabouts in your supply chain you are looking to deliver, we can support you in all sorts of different ways. We work in renewable energy, climate adaptation and mitigation, water management, so all sorts of different areas. And you're going to get a little bit of a flavour for some of the projects that we've been involved in, some of the innovations we've been developing that can support the food and drink supply chain. So our knowledge and expertise covers food, environment and renewable energy, engineering and optimization, and geoscience and technical. And really what we're trying to do is develop time efficient and cost efficient solutions that will help us to deliver various things within the supply chain with a minimum environmental and social impact. We've got 75 years experience of doing this, developing these successful, innovative and bespoke solutions that are ethical, sustainable, environmentally friendly and aligned with things such as the Science Based Targets Initiative and of course the UN's Sustainable Development Goals. To give you a flavour of what RSK looks like, this little map on the right here shows you where our main office areas are, or where our main sites of work are. And you can see that although RSK is a UK-based company, we've got offices across the world with a strong focus within Europe and the Middle East, an increasing presence within Africa, and we've also started moving into Southeast Asia, Australia and South America. At present, we've got about 250 offices across 40 different countries and employees in the region of 12,000 employees. And it's an ever-growing company with many different parts, and hence the reason why you will see different names coming up, ADAS, Calibrate, etc., as well as the RSK brand itself. But as a whole, as a family, we deliver a wide range of different services that are relevant within the food and drink sector. Under climate adaptation and mitigation, we do bespoke climate risk modelling, so understanding where the climate risks are within your supply chain and helping you to develop adaptation strategies to mitigate those risks. So we can do both the design and the implementation of that strategy. When we look at decarbonisation of the product and processes, we're able to provide quantification and reporting of emissions from scope 1 to 3. We've got specialist expertise within agriculture. We can also work within infrastructure and the length of the supply chain. We've got technological solutions as well to support things like heat pumps. We work within the renewable energy sector, so we can design, install and maintain various different types of renewable energy systems, solar, wind, AD, tidal, and then the various different groundwater and air source heat pumps. And we're also able to provide you with technology that can support the optimization of your use of energy, where you can balance your renewable versus grid usage. And Jack's going to speak to you more about that later. In the environment and biodiversity area, we've got all sorts of different activities. ADAS have been working in regenerative or sustainable agricultural practices for decades. We also look at some of these more novel farming systems, things like vertical farming. And wherever we're looking at trying to improve sustainability, we need to make sure that we're optimizing yields so that we still get the food that we need whilst reducing our environmental impact. And we can also look at aspects around nature and environment solutions, biodiversity net gain strategies, capturing of carbon, air quality, facility management, and various other aspects of the environment in which your supply chain sits. We can support within waste and resource management, optimizing water, energy and raw materials, looking at responsible sourcing, supporting in that post-harvest process, enhancing storage and transport, and valorising waste. And we've got a speaker talking about that as well today. We can also support on legal compliance, and we've got the Task Force on Climate-Related Disclosures and Task Force on Nature-Related Financial Disclosures, which we can provide strategic and technical input into. So hopefully that gives you a flavour for the sorts of things that we do. And we work across a wide range of different actors within the supply chain, from corporate businesses, industry, NGOs and levy bodies, through into government departments, both at the UK level and devolved. So I would like to now hand over to Ione, and she is going to speak to you today about how to meet your net zero and ESG targets. Thank you, Ione.
Super, thanks, Sarah. Hello, everybody. So first of all, I'd like to talk about what is sustainability. So essentially, sustainability is a multidimensional concept. It encompasses the integration of environmental, social, and economic factors to ensure the long-term viability and well-being of individuals, communities, and also ecosystems. Sustainability regards the capacity to meet the needs of the present population without compromising the ability for future generations to meet their needs. And this is achieved through finding a balance between the environmental, social, and also the economic landscape to ensure that we can have a long-term well-being for both the people and the planet. So from an environmental perspective, sustainability involves the responsible management and conservation of natural resources. This includes things like water, land, air, and biodiversity, through reducing resource consumption, minimising waste generation, and adopting sustainable practices such as recycling and circular economy. On the social front, sustainability focuses on promoting social equity, inclusivity, and justice. It involves addressing social issues such as poverty, inequality, access to education, healthcare, and essentially basic amenities. So sustainable social practices overall aim to enhance the quality of life for everyone, ensuring equal opportunities and fair treatment. Moving to the economic standpoint, sustainability emphasises the need for fostering economic growth that's both environmentally and also socially responsible. So this entails developing and integrating sustainable practices in supply chains through promoting ethical business conduct, fostering innovation, and that will help to support creation of new sustainable solutions and technologies. To achieve sustainability, various frameworks and tools can be used. So these include things like life cycle assessments, environmental impact assessments, you have sustainability reporting, and also certification verification systems. And these essentially are frameworks and concepts that support organisations and individuals to not only measure, but also manage and report on their sustainable performance. And this enables informed decision making for continuous improvement going forwards. So my next slide was to talk about water and why it's important. So essentially, water is an essential resource, and its efficient management is crucial for ensuring the long-term sustainability of our planet. So the world is currently facing a global growing water scarcity crisis, and this is exacerbated through population growth, climate change, and industrialization. The agri-food industries are amongst one of the largest consumers of water globally, and therefore the industry is dependent on water for its production and succession, and as such is therefore critical to measure and manage water use effectively and efficiently to enable us to minimise negative impacts on production and also support to build climate resilient supply chains going forwards. So in the water scarcity space, ADAS can help with development of water stewardship strategies for farm level through to the catchment scale. So in terms of the water footprints, this describes the total volume of fresh water used directly and also indirectly to produce goods or services. So water intensive processes, these must be identified, and that will enable us to support water efficiency aspects, which can then be evaluated, and this overall will assist in benchmarking for future comparisons so we can track and understand our progress going forwards. So in this area, ADAS supports through providing understanding of the water use from both direct supply chains and also indirectly through modelling exercises. So in terms of the environmental benefits, conservation of freshwater resources is vital, and this is achieved through measuring water consumption, and that will then encourage water saving technologies for development. So on the economic side, reducing consumption reduces water bills and also then reduces energy costs. So consumption increases, consumers increasingly are conscious of environmental issues, and therefore managing and monitoring water use will demonstrate a company's commitment to overall sustainability in the long term. And this then assists to enhance with brand reputation and will also attract environmentally conscious consumers. So in terms of a case study here, ADAS have been working with PepsiCo to improve their water use efficiencies across their global agricultural supply chain for corn and potatoes. And this is across their water stress regions. So far to date, they've experienced an increase in their water use efficiency by 15%, which is quite impactful and significant for these crops since they originally commenced this work in the 2015 baseline. So to conclude for this slide, essentially measuring water use in the food and drink production industries is crucial to support sustainable practices and also responsible water management. Through understanding and monitoring the water footprints, businesses can then identify areas for improvement, reduce their costs, and this will overall enhance the environmental performance of the company. Measurement of water use contributes to conservation efforts of fresh water as well, and that will also support to help with combating the global water crisis. Next slide, please. So moving on to net zero. Why is net zero important, and how can net zero revolutionize the way that we produce and consume food and beverages? So firstly, I think it's important to understand what is net zero. And this is essentially the balance between greenhouse gases emitted to the atmosphere and greenhouse gases removed from the atmosphere or offset. So net zero describes a target which is then achieved through reduction in emissions, and that can increase the carbon removals, or increasing carbon removals as much as possible. And that can be done through then compensating remaining emissions through things like carbon sequestration opportunities, offsetting, or investing in renewable energy projects. So why is net zero important for food production? The global food emissions accounts for 33% of global total emissions. And of this, 2/3 of the emissions are associated almost directly with land use and agriculture. So it's important to have a targeted scope for the 3 agricultural emissions to enable decarbonisation of food and drink. So ADAS here can support with working with farmers to support decarbonisation of supply chains and production activities. Net zero essentially will encourage resource use efficiency, which overall will optimise your production, support to reduce waste, and also promotes sustainable farming practices, ultimately enhancing global food security going forwards for the long term. And that's supported through supply chain resiliency and assists to protect the ecosystems. From the circular economy perspective, this would support to reduce waste through reusing materials and recycling, which minimises the environmental impact of food and drink. So in this area, ADAS conducts organisational assessments that support to develop net zero strategies. We do have experts in mitigation strategies and farmer engagement, and we have specialist knowledge in scope 1, 2 and 3 emissions assessments. So essentially, to conclude for this slide, achieving net zero in the food and drink production is of great importance, and through reducing emissions, conserving resources and enhancing food security, we can support to meet consumer demands long term in a sustainable way. And net zero strategies will assist in navigating towards decarbonisation of the food and drink supply chains that will support to transform the industry to a more sustainable future. Next slide, please. So this slide is essentially just a few examples of some of the net zero projects that ADAS has undertaken historically. So I've mentioned we've done things like scenario modelling, so we can look at the impact of different practices, should they be uptaken, and how that can impact on things like productivity, etc. in the long term. And then we can manipulate the metrics that we assess in the modelling systems so that we can give some different outputs and potential outputs. We've looked at evidence evaluations for various industries throughout agriculture, and these can include beef, dairy, pork, crops and potatoes. We've also done farm level emissions and removals assessments, and we can create and develop essentially a bespoke carbon calculator for an organisation's requirements. And 2 examples of this are one that we've done for the Peak District National Park, and we've also done some for poultry and equine. I appreciate equine doesn't quite sit under the food and drink remit, but we are navigating into the equine space as well. We can also do life cycle assessments of crop inputs and strategy development for net zero long term. And our example of this was one of our projects was for Gressinger, which is one of the largest poultry producers for duck. So, next slide, please. So I just want to talk very briefly about our basis carbon and climate change mitigation training course that we offer. And this is a course that essentially provides candidates with the knowledge and understanding of how carbon and greenhouse gases relate to climate change in agriculture. So our experts will support with presenting the practical tools that can be then used on farm to measure the impact of greenhouse gas emissions, as well as share options for removal. So the aim of this training is essentially to equip the candidates with the skills to promote sustainable farm management practices and make a positive difference to reducing the greenhouse gas emissions. For those that are working in the agricultural sector, this course will improve knowledge of key climate concepts, policy areas, mitigation, and also adaptation opportunities. So the course content covers land management practices, it covers soil health enhancements, farm productivity improvements, and efficiency gains that can be then made with the livestock and crop management sectors. So if anyone would like any further information on the basis course, there are contact emails of my colleagues who will be able to assist you here. Next slide, please. So I'd just like to thank you all for your time, folks, and for listening to my monologue, despite the technical glitches. If anyone has any further questions regarding sustainability or water and net zero, or if you'd like to discuss how ADAS can support your sustainability goals, please do not hesitate to contact me, and you can see my contact details on the slide there. So thank you for your time.
Thank you very much, Ione. So we are now going to move on to Gavin Ramsey, who is going to be focusing on different ways food and drink manufacturing businesses can promote circularity through deriving heat and electrical energy from their waste and byproducts, as well as by producing residues that can be used in agricultural applications. So Gavin, please take it away.
Yeah, thank you very much, Sarah, and good afternoon, everybody. I wanted to talk with you today about improving energy efficiency and carbon reduction within the food and drink manufacturing sector, with a particular focus on how we look at waste, not as a problem that has to be disposed of, but as a resource that can be utilised in such a way that can not only help in the decarbonisation of a manufacturing process, but how it can also result in significant savings in terms of both disposal costs and energy costs. I'll talk a bit about what tools we can use to establish a carbon baseline for a particular process, how we can help identify recommendations for specific improvements to that process, what wastes or byproducts can be targeted to allow for value recovery, and finally how we can help deliver those reductions in carbon emissions and cost. So when we first engage with any client who's looking to improve energy efficiency through carbon reduction, and if they haven't done so already, we utilize a process of carbon management and reduction planning, whereby we establish a baseline for the carbon emissions associated with a particular process or product, carry out an options appraisal of the various ways in which those emissions can be reduced, identify the optimal solution in terms of cost value, and then design and deliver the solutions. It's obviously well established that improving energy efficiency can significantly reduce not only the cost of food and drink production, but also in terms of market accessibility. But where this is particularly effective is where those efficiency improvements can be tied to aspects of the manufacturing process that are of high economic significance. And two of the key economic challenges faced by most manufacturing sectors globally centre around energy security and the cost of dealing with waste in a compliant manner. And any efficiencies that can be obtained from these will have significant impacts on both carbon and cost and allow for the development of more sustainable products. In addition to cost savings, there are now taxation mechanisms and incentive schemes, such as the ETS that exist, that are designed to incentivize the development of low carbon business strategies, and therefore a key service area for us within the food and drink manufacturing sector focuses on the recovery of energy from wastes or byproducts to displace energy generated from fossil fuel sources, as well as reducing the emissions associated with transporting that waste for off-site disposal or reuse. And one of the well-established technologies for achieving this within the food and drink sector is through anaerobic digestion, which, as I'm sure most of you are aware, involves the microbial breakdown of high organic content wastes and byproducts to generate biogas, which can then be used as a low carbon fuel source. We successfully implemented this technology across a range of applications, including in food and drink manufacturing. For example, we've worked with distilleries, such as this one in Speyside in Scotland, where we designed, installed and commissioned an AD process to treat spent lees and pot ale from whisky production. This particular client's production facility is located just outside the village of Cromdale in a very rural area, and they were incurring high levels of cost to transport these materials off-site by road. But through the implementation of an on-site AD facility, they were able to avail of significant cost savings in terms of both heat and electricity, and they now generate over 90% of their heat requirements on-site, as well as generating revenue through incentive schemes. We've done similar projects with clients in the dairy product sector. This particular project was for an AD process to generate biogas from whey residues from cheese manufacturing, with the biogas being cleaned and compressed and then either used on site in a CHP to generate heat and power, or alternatively injected into the national gas grid, which resulted in a significant revenue return for the business, as well as, again, cost and carbon savings associated with reductions in waste handling, haulage and disposal, which all in all amount to around £3 million per year. Another technology that we've worked with is pyrolysis, and in terms of dealing with waste materials, this can be used to thermally treat high organic content wastes that may not be suitable for AD, so things like lower biodegradability materials like wood or woody plant material, and also some plastics. So it can be used to process certain types of food packaging wastes, for example, and can also be used to pyrolyze digestate from AD. The process itself heats the feedstock material typically to between 400 and 500 degrees Celsius in a limited amount of oxygen, so that instead of full combustion, what you get is a thermal degradation or cracking process whereby the feedstock degrades into an elemental carbon char material, which can be classified as a biochar depending on the nature of the feedstock, and can earn carbon credits. The process also produces a syngas, which is rich in hydrogen and sometimes methane, again, depending on the feedstock. And the syngas can be used directly as a gaseous fuel to generate heat and power, or can also potentially be converted into renewable hydrogen fuel. The upshot of this entire process being that instead of these waste materials going for landfill or incineration and their carbon content being emitted to atmosphere, the carbon can be sequestered into a char material that can then be utilized in recycled construction materials or in agricultural applications, as well as for generating low carbon energy. Another form of waste from industrial manufacturing processes is heat. And if you want to reduce the scope 1 and 2 emissions associated with a particular product, very often being able to utilize waste heat from any part of the production process is one of the most effective ways to do that. We've been involved in projects to develop heat networks for that heat to be utilized either back into a manufacturing process or to be used to heat on-site offices or welfare facilities, as well as being used in district networks to provide heat to other industrial or commercial facilities, or indeed in domestic heating. In addition, combustion of biogas from an on-site anaerobic digestion process obviously generates a significant volume of heat. So the implementation of a heat network to capture that and redirect it to where it can be used, again, allows for significant value to be recovered from production wastes. I've mentioned cost as one of the key drivers for looking at decarbonisation within the manufacturing environment, but of course there are a number of others, including legislative and policy drivers such as national net zero targets and the emissions trading scheme. Some businesses might have specific carbon reduction targets either at company or industry level, and consumer demand for more sustainable products is also a key market driver. And finally, a number of studies have identified that reducing atmospheric carbon emissions has a measurable positive impact on human health. So I appreciate that was a very quick run through of some of the ways in which carbon reduction and cost savings as they relate to food and drink manufacturing wastes can be achieved through the services that we provide, but it's hopefully provided some information on the potential for particular technologies to be used to deliver carbon and energy efficiency savings within production processes, and how operational cost savings can be achieved through recovering energy from waste. I'm happy to take any questions once we get to the Q&A session, and of course if anybody has any specific queries in terms of what can be achieved for your business, then please drop me a line. Thank you very much, and I'll hand you back to Sarah.
Thank you very much, Gavin. So we are now going to move on to Jack Smales from Calibrate. And Calibrate are designers, installers and maintainers of commercial and industrial heating, chilling and electricity generating solutions that can cut your electricity bills by up to 50% with their E3 model. So Jack, can I hand over to you, please?
Thank you, Sarah. Good afternoon, everybody. As Sarah mentioned, we are designers, installers and maintainers of heating, chilling and electricity generating solutions on a large commercial scale for a number of industries, including the agricultural sector. And a couple of the case studies and bits that we'll be focusing on today will be related to the agricultural sector, to give you a flavour of what we can do and how we can do that. So as Sarah mentioned, our E3 model is our energy, engineering and environmental model, the 3 E's. What this is essentially is a jigsaw for clients and businesses to achieve their net zero targets, and a bit of a pathway for them to do that, because in reality, for people to become net zero, it's not going to be a one-stop shop. There's going to be multiple aspects of that in doing that, and particularly in agriculture, add in the dynamic of soil structure and various other environmental schemes. It's very much going to be a multifaceted approach, as it is for other commercial and industrial businesses and domestic environments as well, to be able to achieve net zero. And what our E3 model does is it gives you an idea of how you're going to do that. And with Calibrate and with initially our analytics software solution, which is the central cog in that model, we can analyze, monitor and simulate the savings and benefits of a multitude of renewable solutions. So you can see the benefits based on real-time information from your site. We can then work with you to design a system that best suits for step 1. We then install it. We can then maintain it for up to 20 years. And then as part of that jigsaw and that pathway, in year 2 or year 3, when you as a business or as a client are ready to take the next step, we can use the existing software to simulate the next benefit of whether it's step 2 being solar to run the heat pump, whether it's a battery to store that solar energy in, or a battery to store energy from a CHP. It will feed into that and again give you those answers that you need before you actually have to commit to the project, give you those savings and give you those returns. So that's the E3 model, and essentially what we can do is we can add multiple strings or legs or arms to that model depending on what you've got on your site. So a few of the products and services that we've got on screen now are ones that you can see, and also with the wider RSK Group, and also given the fact that we write the code that make the system work, we can bring in a company from within RSK Group or from it outside, and we can add in their software or add in their product onto the whole sort of central brains of the system on your site to make things work in tandem. And that's where the real savings are to be made, in making systems and products and cogs work together so that everything's running at its most optimal efficiency all the time. Now, whether that's a heat pump, as we can see on screen, whether that's a combined heat and power unit or a cogeneration unit to produce electricity, at various times, from hydrogen or biogas or syngas, to either run a heat pump, to run your site process, to store electricity in a battery, put that electricity back into the grid, whatever it may be. The control software and the solution that we're offering is very much a holistic solution for you, and our ultimate goal is to be with you on your journey to net zero through the multiple steps and phases that you will be taking. And particularly on this talk, which is relevant in the agricultural market, there was a lot of interest in the renewable heat incentive, which was an incentive to install renewable heating systems, being biomass or heat pumps, which finished, I think, in 2021 from memory. There are a lot of agricultural installations for this, and what we're finding now is that there's a lot of companies have either fallen by the wayside or are no longer here, and there are a lot of people in a lot of pain and wanting to change their systems, wanting to upgrade them, possibly not running efficiently, wanting to have them overhauled or just maintained. We're finding that there's a lot of people out there that are in need of the services. So a bit of a sales pitch: if you are one of those people with an existing heat pump, please get in touch. And if you're on that road to net zero and you haven't taken any step yet, then the E3 model is a great place to start. And likewise, get in touch on that front. So what we're going to do now is we'll just whiz through a couple of case studies for you so you can see figures and we can put into context what it actually is that we offer and how it can help you. So first case study, grain producer in the Borders in Scotland, an 8 megawatt ground source heat pump system. Now, to give you a bit of context, your average 4-bed farmhouse might require circa 15 kilowatts of heat, and this is 8,000 kilowatts of heat, or 8 megawatts. So to give you an idea of scale, it's a very big system, which was a phased project with this particular client over 3 years, and the installation of 3 phases, ironically over 3 years, and putting various sizes of heat pump into one, reduce fossil fuel input into the site by drying the grain through the grain dryer and on-floor drying floor using the heat from the heat pump. We also used the secondary side of the system on the heat pump, being the chill, to dehumidify the air going onto that grain and onto that drying floor. And the best way to describe it in a functional point of view is, imagine trying to dry something in the Amazon. It's very wet, it's very humid, versus trying to dry something in the desert, very hot, very arid air. It's going to dry a lot quicker. Or imagine, you know, walking through the jungle, you end up being very sweaty and very hot. In the desert, still very hot, but because of that arid and that dehumidified air, it dries the product a lot quicker. So in this instance, we've been drying both grain and grass on an on-floor drying floor system, and the grain through a continuous flow dryer. And we've been able to reduce fossil fuel input, being kerosene on that drying solution, provide dehumidification at the front end to dry the product, and also pre-cool the grain using that chill again, so that the grain is landing into the shed not at 45 degrees or 40 degrees in a big heat, sweating and having to wait for either cold nights to kick in or holding the grain in the dryer for longer periods of time to cool it with ambient air. We can cool it so it hits the shed floor pre-chilled, which increases drying time or throughput time, but also increases the quality of the product, so it's landing into the shed in tip-top condition. There's no worry of it sweating, there's no concern of bugs getting in, and it's a real win for this client, who again have come back for second and third installations, which is proof that what we've done the first time, and a great reward for us that what we've done and the system that we've installed has worked. And this client as well is onto the maintenance contract with 20 years maintenance and warranty, giving them that peace of mind for the system and the ongoing, allowing them to forecast it and budget. And as you can see, the figures on the right there in green, pretty attractive paybacks for that system. On to the next one. This is a a 2 megawatt ground source heat pump project. This is a slightly different application. So we're preheating a steam pasteurization process. And we're also, again, as we talked about the chill, using the chill to chill the grain, we're chilling this soft fruit pasteurized pulp, if you like, from 90 degrees plus down to almost negative temperatures for it then to be packaged up and shipped off for various uses, such as colorings, as flavorings, as what else do they do? Scents for perfumes as well. So this is a very innovative project on its own, and with the heat pump we've managed to massively reduce his fossil fuel input being diesel by preheating the product, even though it's only up to 35 degrees. We've taken a large proportion of that heating element away, which reduces the fossil fuel input significantly, and then are able to cool the product once it's been sterilized, which contributes to the overall efficiency of the heat pump and allows the system to be substantially more efficient than would normally be, because we're able to use both the heating and the chilling of the system with the same amount of electrical input. So traditionally, a lot of people would use a heat pump solely for heating. With a lot of our systems, we try and incorporate the chill to the system as well, which allows and enables the sites to become very, very efficient. It allows them to make additional savings in chiller costs or dehumidification costs that they wouldn't necessarily have had with just a heat pump or using a traditional heat pump method or using a traditional fossil fuel method. Another example is a potato farmer 4 megawatt system down in Shropshire, a very large site in terms of shed capacity. I think there's 15 cold stores. They chill a considerable amount of potatoes for chipping and crisping. So there's a very finite window of and temperature parameter to be set in order to keep those potatoes at the ideal condition and the ideal temperature. And our system and the code that we write that facilitates this based on shed conditions and also ambient conditions has been quite a complex installation to install, and having it being able to produce multiple temperatures at the same time, is quite a feat, and one that is being replicated throughout the country now. And this is very much a showcase site for us, and the technology that's involved not only in the hardware but also the software and the controls of the system is really the backbone and the main driver for this, which again allows the client to monitor also what they're doing now in terms of their heat pump usage, but then also simulate what they can do into the future to help reduce those heat pump costs or further reduce their carbon footprint. And with that analytics system, this client has just installed, I think, in the region of 1.4 megawatts of solar across the roofs to further reduce their electricity bill, further reduce their running costs, and also further reduce their carbon footprint. So with our software, it's not only controlling the system, but it's also facilitating the ongoing reduction of carbon footprint and also cost savings. So I hope that's given you a good insight into Calibrate and what we offer and how we can help people. Details are on the screen. If you have any questions, please drop them into the box and I'll be happy to answer them. Thank you.
Thank you very much, Jack. So we are now going to move on to Stuart Craig, who is RSK's Innovation Manager, and he's going to be talking to us about how RSK manage innovation within the business as a strategic pillar in the development of the RSK Group strategy, and using that as a core competence in delivering first-class solutions to our clients. So Stuart, can I please hand over to you?
Good afternoon, everyone, and thank you for that, Sarah. So, as you'll see from the presentations today, RSK Group businesses innovate to offer valuable and impactful solutions to meet the net zero and ESG targets And as a group, actually, we're really privileged to have so many entrepreneurial and innovative businesses come together to offer end-to-end solutions. So to round off the webinar, I wanted to illustrate our ongoing commitment to innovation and maybe to express its importance, not only to us, but as a major competence in delivering first-class solutions for you and obviously for our wider client base. So I'll briefly cover innovation strategy as we discussed there, and I'll go through what we're doing to grow the culture of innovation as well. So for over 3 decades, RSK Group have been delivering services to support clients in minimising the impact on the planet. And our RSK Group CEO, Alan Ryder, has set out a longer term vision in our 2030 strategy, where a critical component is to diversify our offering across the globe. And innovation has clearly been recognised as a critical component of this. So from the outset, innovation has been a prominent feature in RSK's guiding principles, and it's matured now to become a core competence in our growth, and as such now a strategic pillar. So to illustrate our commitment, our businesses have invested over 64 million in research and development over the last 2 years, and this is growing year on year. So we continue to expand with like-minded complementary businesses and people, and with over 200 businesses currently and an expectation that this will double by 2030, we need to channel our collective capabilities whilst also fostering and building an inclusive culture of innovation. So this has led to the RSK Group Innovation Strategy, which is now known as the Innovation Development Agenda. And it takes a more holistic approach to connecting multiple businesses, divisions and sectors, and then synergising our innovation efforts. So the Innovation Development Agenda, as you can see here, sets out the framework and basically defines the key planning stages to grow innovation capability. You can see here that there's 5 key pillars, and I'll cover some of them in a little bit more detail. So first of all, culture and leadership is really important to RSK Group, and innovation is fully supported by the board and the group senior leadership team. And demonstrating our innovation credentials, it's seen that it's a critical component to winning work, showcasing what we do well, and actually in delivering for our clients. We also are acutely aware that governance and management is incredibly important, and it's a prerequisite to actually delivering. So we've built a network of innovation leads and influencers across all of the divisions and all the sectors, with a clear remit to connect, share and develop solutions. And in addition, we've created a portfolio, we've developed a portfolio manager of all of our, and well, we're still growing it, but with innovation projects and solutions. And we don't just align with our business goals in using this, but we can optimize what we can offer you now, and we can also look at what we need to develop in the future to meet the future needs. So we've got far more visibility of embedded and potential solutions, and in working closely with you to meet your challenges, we can prioritize the investment in the most valuable and impactful for yourself. And this visibility also means that we can respond quickly, which is incredibly important. So it's a real critical enabler when engaging with all of our key clients. Now, promotion and visibility is extremely important as well. I mean, innovation should be completely inclusive, and we want to make sure that everybody across the globe within our business has access to it. So the strategy, obviously, with this inclusivity, requires visibility, and as such, not just for the portfolio of solutions, but in a wide range of content that can be used to leverage our experience and our knowledge that can be then used to offer the best solutions. And this includes an innovation portal that we've designed, an innovation inventory, which is a central repository of embedded demonstrable innovative solutions, and lots of learning resources within that as well. It also provides access to innovation platforms that we've developed, including the Global Innovation Ideas Hub, and this was launched last year. And you know, we also like to celebrate innovation, so we are currently underway with our annual Global Innovation Awards, and this is our 6th year having these. It's a fantastic event, and the amount of the participation is incredible. We've got a record year this year with 120 entries, anything from an incremental solution right through to a massive infrastructure project and all the innovation that goes on within that. So it's an incredibly useful resource as well in identifying cross-sector and industry solutions that can be deployed quickly or to start a working partnership. Then for engagement and collaboration, so I did mention the hub. The Innovation Hub provides an opportunity for every individual at RSK to record ideas and be acknowledged and have them entered into our innovation funnel. Now, the greatest thing about this is we've got 15,000 employees now, and that's going to grow exponentially with the growth strategy that we've got. So the Innovation Hub is a really powerful tool in capturing potential new solutions for all of our clients. We also recognise the value in collaboration and the importance of cross-divisional and sector knowledge share. So we now invite subject matter experts to a number of internal and external events, and these include like hackathons or speed date events with clients. And our individual businesses do continue to innovate independently too, as you've seen today. And as an extension of this, the strategy makes it easy to offer multiple aligned solutions. And then finally, in one of the pillars that we've got here, innovation challenges and partnerships. So it's a critical strategic arm in as much as we need to set up open innovation challenges and look for opportunities to partner with startups and corporates and clearly with our clients. We also take advantage of opportunities to partner with universities and higher education. So just recently, one of these included Newcastle University, and they are now researching water coagulants. So essentially the whole life cycle cost, environmental impact and alternative technologies. And in our partnership with Salford University and academic industry collaboration to support the delivery of net zero and new and existing buildings. We focus on sustainable materials and artificial intelligence. This includes running digital twins to test performance with bespoke software. We also have one of our businesses liaising with, or working with, should I say, with University of Sheffield, looking at a multi-system digital tool to create a digital renewable energy systems tool. Easy for me to say. So essentially this is to support the feasibility assessment of renewable energy systems for the clients. And we've also recently set up a partnership with the University of Greenwich. So this partnership is designed to empower the university to shape its green skills agenda and the creation of a green skills academy. So there's a lot of involvement outside of our business and a lot more connections that we can make to advance our innovation offerings. So apologies. So first of all, I'd like to say that our portfolio is vast. I mean, we cover 9 sectors, 200 businesses. Everyone is innovating. We can't even begin to actually capture every single one of them at the moment. So the portfolio is designed to do just that, so that we can actually maximise our potential for delivering multiple solutions. But we've had a bit of a deep dive today, and I just wanted to highlight some of note. So the first one that we've got here is process emission pathways solution. So basically enabling the identification and reduction of greenhouse gases. This is an award-winning computational fluid dynamics N2O model. So essentially predicting emissions from treatment facilities in full 3D, which drastically enhances process understanding and modelling, can enable emission mitigation strategies. Yeah, it can be, with current methods, it eliminates time and cost associated with intensive sampling regimes. So essentially we're expediting the process as well. Secondly, we've got plant protection products, fate and behaviour modelling automation. So essentially modelling automation, the drive to improve agricultural efficiency to boost crop yields and increase food availability. And this innovation has seen an 80% efficiency improvement and negates the need for analysing multiple data sources and basically expedites the delivery of the information to our clients. We also have Smart Water Future. So this is an innovative irrigation system in collaboration with 2 major growers, delivering major sustainability outcomes and multiple benefits for the local environment. The scheme reduces discharge into the rivers, and I've got some stats that say 11 tonnes of nitrogen and 1.8 tonnes of phosphorus were diverted from the river system. The scheme saw the design and build of a 22-kilometre pipeline network and a pumping infrastructure to deliver about 2.6 gigalitres of Class A water per year to the region's growers. The big benefit of this scheme is dependable irrigation. So it'll give the growing farms the confidence to expand their operation, to meet increased demand for the produce, to maintain production through dry spells, to hire people knowing that there's work for them, and it builds stability and dependability for workers, distributors and consumers. Next one, climate change impact modelling. So I only discussed the modelling capabilities that we have. We've got a number of solutions here, appraising the likelihood of future climate hazards and to assess the potential impact of climate change related risk in assets and operations. And this modelling and in its data analysis basically transforms solid scientific data into decision useful information. So providing information on how certain hazards will change at a regional level or a local scale for near, medium and long-term future. And managing this climate risk and managing the climate-related risk provides opportunities for businesses to enhance their resilience, reduce operational costs and create mitigation strategies. Next one is floating photovoltaic systems. So we're basically developing these systems for use on small water bodies. We've seen them in large sea and large rivers, etc. But in small water bodies, these are designed to conserve valuable land and resource and mitigate negative biodiversity impact. And finally, digital innovation and design and construction. So built environment, we have digital design and construction where digital delivery is used to enhance the quality and efficiency of the design and construction process from concept to commissioning. And we use digital toolkits to actually do this, which enable pre-project modelling. So for instance, virtual project preparation using laser scanning, 3D model conversions, federated 3D models and 4D scheduling, to name but a few. We also innovate to provide life cycle insights and remote sensor applications in the form of a true digital twin, which can forecast asset failure and facilitate real-time remote asset inspection and reparation. So that's just a brief insight into some of, well, a very small amount of the innovation that we've got that may be of benefit. I think it's incredible this year, the vast scale of innovation that's happening within the business at the moment. So as you can see, in RSK Group, we're committed to synergising our innovative solutions and providing end-to-end solutions. And in our growth strategy, we'll continue to build on our innovation capability to meet the future needs of our clients. So please reach out, and thank you very much, everyone.
Thank you very much, Craig. So that brings our presentations to a conclusion. And I think there's kind of a number of key messages really that have come out of those presentations. We need to be able to measure in order to be able to manage, whether that be water, whether that be carbon emissions, greenhouse gas emissions, energy usage. The better we can measure it and monitor it, the better we can manage it. By optimizing our energy use, we can decarbonize some of these infrastructure projects and help make the use of renewables on your farms or within your supply chains more effective. It's possible to valorize waste and not only get value from it, but also reduce your costs and capture carbon. And then innovation is really going to be a key part in how we deliver that piece going forwards. And RSK are really working to ensure that we have innovative solutions to support the food and drink supply chain. So I am now going to open up the floor for questions, and I will invite all of the speakers to turn their cameras back on. We'll remove the slides so that we can have a little bit of a discussion session. Anybody who's got, please do put your questions in the chat box or the question box, and we will then read those out. So the first question that I've got is for Jack, and it says all the case studies that were given seem to incorporate renewable heat incentive, which is no longer available. So what are the paybacks like on your systems with this?
So good question. Thank you. Yes, they do. The answer is still very good, and to put a finite figure on that is difficult because the question to the client or the person asking the question is, what are your pain points? Where can we save you money? Because it's not just carbon, it's not just cost. There will be other benefits to the system which contribute to that payback, which will decrease it for you. So without the RHI, subject to what your setup is, it could be anywhere from 2 to 5 years payback. But again, it's how we incorporate other aspects of the system into your current process to save you additional money, and whether that's reducing your chiller input, whether that's reducing your fossil fuel, whether that's adding an extra revenue stream to your business by being able to dry a product using waste heat or any excess heat that you have. So a difficult one to answer and put a figure on. Still very, very attractive, significant savings and returns on investment in terms of carbon reduction, which is fantastic. But it's also, how do we incorporate other aspects of the renewable package, i.e. solar or battery or wind or hydrogen production, to again further facilitate that return on investment. A wishy-washy answer, which is probably not what you're after. In a nutshell, returns are still very good, very incentivized on carbon and also cost. Our objective is not to make you pay more, but look at how we can reduce your cost, but also reduce your carbon as well, from a holistic point of view.
Thank you very much, Jack. So next question here, which will fall in part to Ione and maybe also to Gavin, and that is, how can the food and drink sector effectively reduce food waste and its associated environmental impacts? So Ione, would you like to start first, and then Gavin, you can maybe think about some of the environmental impacts of waste valorisation?
That's a very good question. So essentially, food waste is a significant environmental challenge, as we all know, and the food and drink sector can play quite a crucial role in reducing it. So some effective strategies would include supply chain management, things like consumer education and awareness, food rescue and redistribution, and other approaches to circular economy. So essentially, implementing efficient supply chain management practices such as improved inventory management, optimized packaging, and enhancing the transportation logistics would all support to minimize food loss and reduce waste at various stages of the supply chain. I would say that utilizing technologies as a driving factor for solutions such as real-time tracking, data analytics, can also help to identify and address inefficiencies. Another thing you could look at as well is, say, education of the consumers on the impacts of food waste. So providing guidance on proper food storage, portion control, expiration date understanding can also help to reduce household waste overall. And then encouraging, say, responsible purchasing habits, such as buying only what's needed, highlighting ways to utilize the leftovers. That would also support to contribute towards waste reduction in the food and drink sector. In terms of, say, food rescue and redistribution, I would say that collaborating with food banks, charities, organisations that are dedicated to food rescue and redistribution could also then help to support with redirection of supply to help with supplying food to those in need as well. So another perspective I would say is implementing donation programs. So establishing partnerships, utilising innovative distribution methods as well would also help to ensure edible food waste is not edible food is not wasted. Edible food waste is not wasted. And then that would also support to encourage food to reach vulnerable populations as well. So.
Thank you, Ione. Gavin, do you have anything to add in terms of management of food waste?
Yeah, I mean, as Ione's touched on, at the point of use, you know, obviously things like supply chain management and things like that can be utilised to reduce actual food waste production. From a manufacturing point of view, obviously some byproducts or wastes are pretty much unavoidable. There may be a necessary part of the actual production of the final product itself. and where the impacts on that can be reduced can be either reusing those byproducts on site, either putting them to another use, recirculating them back into the manufacturing process if possible, or potentially utilising them in some form of recovering value from them on site, as I touched on in the presentation. The key thing around that being is you're retaining the impact on site, so you're not having to send the material off site with the added environmental impacts and potential carbon impacts that comes with that. So that's potentially one way that you could look at it from a manufacturing point of view.
Thank you, Gavin. Okay, so Jack, heading back to you. How efficient are heat pumps, and how can they be used in agricultural settings, and what are the benefits?
Good question. So in terms of efficiencies, traditional efficiencies for a ground source heat pump using the heating only is in the region of 4.5 to 5% efficiency. So what that means is for 1 kilowatt of electricity in, you get 5 kilowatts of heat out. So we would call that a 5% COP or a 500% efficient unit. Bearing in mind what we at Calibrate do with the chilled side of the system in terms of dehumidifying and using that chill for your process, with that same kilowatt of electricity that you're putting in to get 5 kilowatts of heat out with, on the other side of the refrigeration circuit, we're also then going to give you in the region of, let's say, 3.5 kilowatts of chill for that same kilowatt of electricity. So 5 plus 3.5 gives you 8.5% efficiency, or an 850% efficient machine, which is incredibly efficient. And one of the other benefits of incorporating that chilled side of the heat pump into your process, air source heat pumps historically are slightly less efficient than heat pumps. However, there's a less capex cost at the front end because you don't have the pipe to put in the ground or the boreholes to drill and dig. Traditionally, air source heat pumps are around 3% efficient on the heating side. Some of the better efficiencies are at 3.5, but again, depending on the time of year, that efficiency goes up and down. But I'd say they were fair averages for the year as it goes through.
Okay, thank you.
Second part of that question, please, Sarah. So there was a second part to that, and it slightly evaded me.
How can they be used in agricultural settings, and what are the benefits?
So across a multitude of agricultural settings and across livestock. So, for example, providing heat for chicken sheds, providing grain drying facilities, providing other forms of drying. And I know we talked about on the AD front there through Gavin, you know, recovering any of those products and waste products that we have and maximizing essentially their value. It is key, and whether that's bedding and recycling bedding, whether that's using the chilled side for milk chilling if you're a dairy farmer, chilling potatoes, soft fruit environments, chilling onions, setting the skins, whatever that may be. There are lots of agricultural process, and I've probably missed off masses, and I'll be kicking myself after it that I haven't mentioned them for you. But essentially any facility or process that requires heat or chill, a heat pump and or a CHP can apply that technology to you to reduce your carbon and also your cost input. So lots is the answer to that. Have a look on the website, lots of case studies as well.
Okay, brilliant. Thank you very much, Jack. And Gavin, one final question for you. How do I get access to biochar to use on my farm?
Well, this is certainly an expanding market within the UK and also elsewhere within Europe. There's certainly a number of different projects coming online, focusing on dealing with you know, things like plant materials and plant wastes and the production of biochar from those. I think the key thing with this is to, I think you can certainly have a look at some of the accreditation bodies that are involved for accrediting biochar for use in agriculture, and they'll give you an idea as to who's actually producing these materials, or talk to ourselves. We have quite a broad scope of knowledge in terms of what projects are currently ongoing or potentially in development, and on a regional level where biochar may potentially be available within the market.
Okay, thank you very much, everyone. Thank you to our speakers for your useful insights today. Those of you who have listened, thank you very much for joining us. If you would like to hear more and see more of what RSK are up to, please do take a look at our events website. We've got a series of webinars that are lined up ahead of the COP3, the Countryside COP3 event, which takes place next week's time, 2 weeks' time. So please do take a look at that. Emma has just shared a link to that within the chat box. So thank you very much for joining us, and I hope that you will join us on future webinars going forwards. Thank you all. Bye.
Thank you. Bye-bye.
Bye-bye.
Thank you.